The optical head is the main part of any stereo microscope. It is the component that creates the three-dimensional image and determines how comfortable and precise our work can be. Everything depends on the quality of its design: image clarity, depth of field, viewing angle, and overall comfort during extended use. The optical head combines the objective lens with a zoom mechanism, a system of prisms and mirrors, and the visual part with the eyepieces. Let's start with the objective part. For convenience during filming, all the heads are currently mounted on compact stands. This makes it easier to show the details. The magnification of the pancreatic objective changes smoothly, without loss of quality, and while maintaining a working distance of 105 millimeters. In the Series 7, the magnification range is from 0.67 times to 4.5 times, which gives a zoom ratio, or in other words, a zoom factor of 6.7 to 1. And in the Series 8, the magnification changes from 0.65 times to 5.5 times, meaning the zoom factor is already 8.4 to 1. The higher the zoom factor, the more complex and expensive the optical system becomes. The magnification of the microscope is changed by rotating this handle. The numbers on the handle indicate the objective magnification. The magnification of Stereo 7 microscopes in the basic configuration with 10 times eyepieces ranges from 6.7 to 45 times. The magnification of the Stereo 8 microscope in the basic configuration ranges from 6.5 to 55 times. Objective attachments change the working distance, the magnification of the microscope, and the field of view. A 0.5 times attachment increases the working distance and widens the field of view. Such an attachment is suitable for precise manipulations under the microscope with a soldering iron, brush, or scalpel. For this kind of work, you need a large field of view and free space above the object, while high magnification is not necessary. 1.5 and 2 times attachments, on the contrary, reduce the working distance and the field of view. These attachments are used when magnification above 90 times is required. Inside the head, there are prisms and mirrors. They direct light into each eyepiece separately, creating a stereo effect and forming a direct, non-inverted image. We've covered the objective part, now let's move on to the visual part of the optical head. The eyepiece tubes of the visual attachment can be adjusted for interpupillary distances from 54 to 75 millimeters. They are fitted with 10 times eyepieces with a field of view of 22 millimeters. The eye relief allows for comfortable use both with and without glasses. Flat rubber eye cups protect the lenses of glasses from scratches. The eye cups are removable. The eyepieces are securely fastened with screws, so they won't fall out during transport. The mounting diameter is standard 30 millimeters. Both eyepieces have a diopter ring, allowing the image to be adjusted to the user's vision. When the eyepieces are changed, the microscope's magnification and field of view change, but the working distance remains the same. The standard kit includes only the basic 10 times eyepieces, but you can also order a 10 times eyepiece with a scale, as well as eyepieces with 15 times, 20 times, 25 times, and even 30 times magnification. So, we've determined that the main difference between the 7 and 8 series lies in the magnification of the objective and therefore the optical head as well. However, within each series, the microscopes differ in the design of the head, binocular and trinocular. Trinocular models allow you to install a digital camera in a separate vertical tube, the imaging channel. Important? The C-mount adapter is not included in the kit. Depending on the camera sensor and your needs, choose either a 0.5 times or 1 times adapter. The camera transmits the image to the screen of a digital device. The division of the light beam is fixed. 50% of the light goes to the eyepieces and 50% to the imaging channel. The image is simultaneously sent both to the eyepieces and to the camera. This solution has a number of advantages. You can observe and record what is happening at the same time. This is convenient for teachers, presentations, and video documentation of experiments. There is no light path switching lever, which means less wear and fewer mechanical issues. The image is sent to the camera regardless of observation through the eyepieces, so you can record continuously without interfering with the operator's work.